so far with that. The first one we saw was slope-intercept form. You don't need to write this down. We got these in other notes. And that would be y equals mx plus b. This is a great way to write the equation of a line if you have the slope of the line m and the y-intercept of the line b. We've seen that already. The other form that we've seen so far is standard form. That's that ax plus by equals c. This is an excellent one. And we'll see a better use of this type of form when we get into word problems. This form is best used just in general with word problems. And then if you have to graph something from a word problem, that's a good form to go from there as well. We learned how to graph these using the x and the y intercepts. Plug in 0 for x, solve for y, plug in 0 for y and solve for x. We also learned how to convert this into slope-intercept form back to this way right here, because generally speaking, it's going to be easiest to graph from slope-intercept form. The third and final form of an equation of a line that we're going to see is called point-slope form. And this one is more similar to slope-intercept, whereas slope-intercept, you're given the slope and the y-intercept. Point-slope, it is kind of what it says. You have a point on the line. Good morning, welcome. You have a point on the line and you are given the slope of the line. So this one is also a pretty useful form for graphing. However, we're not really going to be graphing from point slope form. We're going to take point slope form and convert it into slope intercept, just to keep that consistency going, because for the most part, graphing from slope intercept is going to be the best way to graph, and it's good to just keep things consistent. You can graph from point slope, but we're not going to worry about that right now anyway. So let's dive in. It says, writing linear equations given a point and the slope. So that's the whole name here. Given the point and a slope, point slope form. To write the equation of a line passing through a point x1, y1. So it's just passing through a specific point on a line. That's why the 1 is there. It's not just a random xy, it's a specific x1, y1. With a slope of m, we're still using m for slope, thank goodness, we didn't change that. You can use the point slope formula. And like with a lot of things, I'm going to be using different colors to represent different parts of this. So I'm going to have y, and this is a strange looking equation, by the way. I'm just going to let you know, and I'll talk about why I think a lot of people have a hard time with this one, because some people do. However, it's not really a crazy formula. It is y minus y1 equals, and then the slope m times, in parentheses, x minus x1. I'm hoping those colors are showing up okay. The blue doesn't look very blue. The x1, this is blue. Kind of. Not the best on the camera. Okay. So it's y minus y1 equals m, and then times, in parentheses, x minus x1. So what we're looking at here is the x and the y are just like the regular x and the regular y. This y and this x are just like the x and the y in y equals mx plus b and the ax plus by equals c. They are random, any xy coordinates in that particular line. The specific with the ones here, that is a specific point on the graph. The x and the y will remain x and y. The x1 and y1 will be replaced with numbers, and the m will also be replaced with a number, the slope. We know m equals slope, and then x1, y1 is another point. So the thing that I think throws people off the most is that you are so used to seeing equations, and when they are quote unquote done, right? When you're done with an equation, it usually means there's only one thing on the side of an equation to be done with an equation. This one's going to look a little funky because you're going to have multiple things on both sides of the equation, which is not normal for you to see. Usually we see things like, hey, there's a y by itself right here. There's a c by itself over here. This one doesn't have that. It's got 2 things over here and 3 things over here. And that's the way it's written. And so if you write an answer like this, this could be written as a final answer when you plug numbers into it. It looks unfinished. And I think that's where people have a hard time with it. It looks like you're not done with the problem. So let's go ahead and try this out. It says for the directions, write the equation of the line that passes through the given point and has the given slope. Write all answers in slope-intercept form. So we are going to do a little bit of algebra. Every single one of these will require 2 algebra steps. It's a distributive property, and then you're going to add or subtract on every single one when we do this. So I'll show you what that looks like as well. All right. So our x1 value is the x coordinate of this point. So here's the point, 4, 1. So the 4, that's x1. This 1 here, that's the y coordinate, the specific y coordinate that we're given. So that would be the y1 right there. The slope is m, so that one is 2. So there's m right there. And what we're going to do is plug those in to this formula right here. So we're going to have y minus the value of y1, which is 1. So y minus 1 equals then the value of the slope, m, which is 2. So y minus 1 equals 2. And then times, in parentheses, x minus the value of x1, which is 4. So that right there, that is the point slope form of the equation. And if you were being asked to write an answer in point slope form, this would be your answer. It looks funky, it looks unfinished. You've got multiple things on both sides of the equation, but that's just how it works. It's a strange thing to get used to. I think the confusion for a lot of people comes in like, well, why we're not done with this yet, are we? And the answer for the most part is, yeah, we are. However, in this particular case, we're not finished because we have this other direction up here. Write all of your answers in slope-intercept form. So getting an equation into slope-intercept form means getting y by itself. So one thing we have to do is get rid of the parentheses over on the right-hand side. And then the other thing we have to do is get rid of our -1 in this particular case here. So I'm just going to do a little bit of note-taking on the side here. Let's see, to go ahead and write this down. To convert from point slope form into slope-intercept form, step 1, distribute the slope. Step 2, add or subtract the value of y1. Running out of green ink. All right. Switch up that pen. So to convert from point slope form into slope-intercept form, distribute the slope, and then add or subtract the value of y1. So we're just going to do 2 steps to make this happen. We got to get y by itself, and we're going to use 2 steps of algebra. The first step is to distribute the slope. So the reason why we have to distribute it is because we have a number on the outside of parentheses. We need to get rid of the parentheses. So we're going to take that 2. And we're going to multiply it by distributing it to the x and to that -4. Actually, I'll leave those directions up there as well. Hopefully we can all see this. Okay. So we distribute the 2. That's our first step in this particular case. Nothing happens on the left side of the equation here. So we just leave this as y minus 1. And that's going to equal, on the right-hand side, 2 times x is just 2x. And 2 times -4 is -8. So we get y minus 1 equals 2x minus 8. So there's step 1. We distributed the slope. And then step 2 says to add or subtract the value of y1. Well, the value of y1 is 1, but it's a -1 in the equation. So to get rid of a -1, we have to add 1 to both sides. We're going to add 1 here. And just as a reminder, when we add 1 on the right-hand side, I'm not going to write +1 underneath my 2x. I can't add 1 to the 2x, but I can add 1 to the -8. So I'm going to add the 1 with the term that I can actually combine it with. It doesn't do me any good to put it underneath the 2x because we can't put those together, but we can do a -8 + 1. That does work. On the left-hand side, the -1 and the +1 cancel out, and we're left with y equals 2x, and then -8 + 1 is -7. So 2x minus 7. So this line, we already knew it had a slope of 2. And if we take a look here, it still, in the final answer, has a slope of 2 because even in point slope form up here, we have a slope of 2. And then in slope intercept form down here, we have a slope of 2, which makes sense because it's the same line. So that is, I think, every single thing we're going to be doing today. Yep, that's it. We're just going to do that process today another 15 times. So we're going to practice this over and over and over. Hopefully by the end of the lesson, you're going to be like, oh, I get it already. It's fine. Let me get the assignments. Hopefully that's your approach to this, is that you just understand it by the time we're done, and then we can get working on the assignment. So let's try problem number 2. Here we go. Number 2, we have to write our equation in point slope form first. Our point is 2, 4. The value of x1 is the first number because that's the x coordinate. So there's x1. The value of y1 is the y coordinate here, which is 4. So there's y1. And our slope, m, is equal to 1/2. So there's m right there. I'm going to need to grab a different pen here in a second. Maybe I have a colored pencil. Let's see. Yes. All right. There, much better. Okay. So we got x1, we got y1, we've got m. Now we're going to go ahead and throw this into point slope form. So we've got y. We're just going to copy down this exact formula up here, but we're replacing y1 with 4. We're replacing m with 1/2, and we're replacing x1 with 2. So we've got y minus the value of y1 is 4 equals the slope m, which this time is 1/2 or 1/2, times, in parentheses, x minus x1, which is 2. So this is just straight substitution to start off. So there's step 1, or not step 1, but just there's the equation for point slope form. Then we're going to follow the 2 steps to convert from point slope into slope intercept. So over here, it says that step 1 is to distribute the slope. Our slope is 1/2. We're going to distribute 1/2 to x and 1/2 to -2. That's where we're starting. So nothing happens on the left-hand side yet. It's going to be y minus 4 equals 1/2 times x is just 1/2 times x, 1/2 x. And then 1/2 times -2, half of -2, that's -1. So 1/2 x minus 1. So there's step 1, we distribute it. And if you end up needing to use a calculator when we get into some other fractions, like the next one, 2/3, and the one after that, -3/4. If you need to use a calculator for some of these, that's totally fine. All right, and then finally, the last step, step 2, we have to add or subtract the value of y1. Add or subtract the value of y1 from both sides. So we have to get rid of our -4 right here by adding 4 to both sides. So +4. And again, I'm not going to put +4 under the x term. I'm going to put +4 under my regular number over here, the -1. So there's +4 over there. Line it up with your like terms. So then the slope-intercept equation, we've got y equals, that's what we wanted, 1/2 x, and then -1 plus 4 is +3. So our slope-intercept equation for problem number 2, y equals 1/2x plus 3. Are there any questions on the first two problems before we continue? All right. So let's go ahead and try number 3. This one's going to be a little bit different, not only because of the 0, but because this time our x1 value has a negative. That'll make it look a little different in the point slope formula equation. I'll show you in a second. X1 is -6. Y1 is 0. M is 2/3. And then we're going to substitute those into the formula. So we start with y minus y1, which this time is 0. That'll be actually pretty convenient for this problem. I'll show you in a second. Y minus 0 equals. M is 2/3, so 2/3, and then times in parentheses, x minus, the value of x1 is -6. So x minus, we have another negative in here now, -6. I'm going to need to swap out this pen pretty soon too. All right. So let's see. First question, what can we do with this y minus 0? What's that? Yeah, we could absolutely follow the steps, but if it's and that will work. But if we add 0, does that change anything? Not going to do anything. So we don't actually need it. We can cross that out. That doesn't need to be there. Plus 0, minus 0 in this particular form of an equation, it's actually kind of getting in our way, which means this is only going to take one step. Because once we distribute the slope, it's just going to be y equals. Now, the other thing I want to mention is over here. X minus -6. Is there another way to write this? Yeah. Instead of x minus -6, we're going to go with x plus 6. So if your x1 or your y1 is a negative number, when you write point slope form, it's not going to be minus, it's actually going to be plus, because that means you'd be subtracting a negative. And when you subtract a negative, that's just the same as adding. So instead of x minus -6, we're going to write x plus 6. Because if you try to distribute into a double negative, it just makes it a little bit more challenging. Let's just go ahead and turn our double negatives into positives, because that's what happens. So now we can work through this process, and there's only one step to solve this one, because this is just y over here now. And so when we distribute our slope, we're going to end up with y equals, because the 0 doesn't change anything. 2/3 times x is just 2/3 x. And then 2/3 times 6 is going to be 4. And so that'll be plus 4. And again, if you want to use a calculator to do this, that's totally fine. The way that I do this, usually using mental math, is I'll take the numerator, I'll multiply it by the whole number. 6 times 2 is 12, and then divide by the denominator. 12 divided by 3 is 4. So you can just do that. When you're multiplying a whole number by a fraction, multiply the numerator by the whole number and then divide by the denominator, and that's your answer. So 2 times 6 is 12, 12 divided by 3 is 4. So the answer here in slope-intercept form, we get y equals 2/3x plus 4. All right, we're going to do one more together, and then I'm going to have you try a couple on your own. So number 4, we've got x1. It's the -8. We're going to have y1. That's our -1. M, our slope, is -3/4. We're going to take those three things. We are going to plug them into point slope form. Now, because both of our values of x1, y1 are negative, instead of writing minus -1 when we write this one here, instead of writing y minus -1, we're going to write y plus 1 equals -3/4 and then in parentheses times x. Instead of writing minus -8, we're going to write x plus 8. Now, we're going to go through our 2 steps. First thing, we have to distribute the slope, -3/4. That distributes to the x and to the 8. And just a reminder, when you distribute, you are distributing by multiplying. The left side of the equation doesn't change. It's still y plus 1. We haven't done anything over there yet. Anytime you multiply a fraction by a variable, you can just put the fraction next to the variable, -3/4x. Just put them together. And then -3/4 times 8 is going to be -3 times 8, which is -24. And -24 divided by 4 is -6. So that would be -3/4x minus 6. So there's step 1 from our directions over here, distribute the slope. Step 2, add or subtract the value of y1. So this time we have to get rid of a +1. So that means we're subtracting 1 from both sides of the equation. So that'll give us y equals -3/4x, and then -6 minus 1 is -7. All right. So I'm going to give you, let's say, 2.5 minutes or so. Why is it +1 here? If it was -1 here? Yeah, because if we were to write this out using the minuses, we would have written, let's put it here, y minus -1 equals -3/4 times x minus -8. The reason is because the formula itself has subtraction, and then the y1 value had its own negative as well. And so it's double negative here, subtracting a negative, and that's always a little bit more simplified to write it just as a plus. So subtracting a negative is always the same as just adding. So if your y1 value is a negative, you can write +1 or whatever, plus whatever it is. It's kind of like the opposite of whatever the value is. So x1 was a negative as well, so we write +8. If we look at the first 2 problems, when x1 and y1 were both positive, we left these as a minus right there. But because those values are now negative, it turns it around and makes it a plus. So, and that has everything to do with the fact that there's a minus in the formula. And so if you put another negative with the minus, turns it around and makes it a plus. So good question. Is that, yeah? Okay. So we got y equals -3/4x minus 7 for our answer on number 4. All right. I'm going to give you, like I said, about 2.5, 3 minutes. Try out number 5. See what you can do with it. If you have questions on it, let me know. If you struggle on this first one on your own, I get it. It's totally normal. Just keep practicing. We got a lot more problems to get through today. Hopefully by the time we are done with the notes, you'll feel a little bit better about what we're doing. So try that one, number 5, and I'll help out if you need it. grab one of each of those. All right. So go ahead and take a look up here. We've got y minus -3 equals -1 times in parentheses x minus 4. Before we start working through the two steps to make this into slope-intercept, what should I change about how this looks before moving on? What's the one thing I need to change here? How do I need to make this look a little bit different before we start going through those two steps? So even before we distribute, there's one thing that I'm going to make an adjustment to here, Elena. What's that? +3? Yeah. The minus -3, because we had a negative value for our x1 or y1, we're just going to make it a positive. We're going to not make it a positive, sorry. We're going to turn the double negative into a plus. We're not changing the negative to a positive. It's still a negative. It's just the way it interacts with the minus, it becomes a plus. So now we can distribute. So we'll distribute our -1. And so that'll be y plus 3, nothing changes on the left. And then we'll have -1x, -1 times -4 is +4. So that'll give us y plus 3 equals -1x plus 4. If you don't have this so far, make sure you have this written down now. If you need to make any changes, go ahead and make those changes. And then the very last thing we're going to do is get rid of this 3, which means we just subtract it from both sides. So -3 here and -3 here. And so that'll be y equals -1x, 4 minus 3 is 1. So -1x plus 1. And that's our slope-intercept form right there. All right. So I'm going to go ahead and stop using the colors now. We've seen a few examples with this altogether. I've used it all the way through for the first 3, dropped it from the equations on 4 and 5. Now it's going to be gone for good. So number 6, we've got x1 is 0, y1 is -9, m, our slope is 4. If you worked on this one already, great. Take a look, see how you did. So on the left-hand side, it's going to be y minus -9, which means I'm going to write y plus 9 equals 4, and then times in parentheses x minus x1, which is 0. All right, next, we'll go ahead and distribute our 4. And then this is still y plus 9 equals 4 times x is 4x. And then 4 times 0 is still 0. So you could just leave this as 4x, that's fine. Or you could leave this still as a -0, either way. The -0 might be helpful in terms of where to put the -9 when you subtract 9 from both sides, because that'll be our second step. So we're going to add or subtract the value over here with the y. So that means we need to get rid of a +9. So we're going to subtract 9 from both sides. And so that'll give us y equals 4x. And then 0 minus 9 is just -9. So 4x minus 9. And so there's our slope-intercept equation right there. Are there any questions about this one before we take a look at page 2? Yeah. There's going to be a little bit of a wait. I'll let you know when. We got a few people waiting on the pass. All right. Questions on anything on the first 6 problems before we start looking at the rest of them? Okay. Go ahead and flip it on over here. I'm going to take a look at some of these, and I don't think we're going to go through every single one of these problems. I will, when I post these online, the filled in notes, I will have every single answer on here for the notes online, but I don't think we're going to go through every single one of these, because we've pretty much looked at every type of variety that we are going to go over. So let's go with, let's see, just taking a look here. Let's just do the odds. We'll do 7, 9, 11, 13, and 15. And then 8 through 16 evens. I will put those on Google Classroom, but we won't fill those out during class. I want to make sure you've got lots of time to get started on your assignment today. So here we go, number 7. So we're starting with x1 here is -12, y1 is -5, m equals 1/3. All right. Do I have any volunteers? How am I going to write this in point slope form first?
Y plus 5 equals 1/3 x minus.
Yeah, exactly. Nice job. Y plus 5, y minus -5 is y plus 5 equals m 1/3 times in parentheses x minus -12. Minus -12 is the same as x plus 12. Awesome. So that's our point slope equation right there. All right, now we're ready to work on our 2 algebra steps. What do we do for our first algebra step? What's our first algebra step going to be? Go ahead, Graydon. Yeah. Yep. Yeah, y plus 5 equals 1/3x plus 4. Nice. Again, to do this multiplication quickly, numerator 1 times whole number 12. 1 times 12 is 12. Divide by 3. 12 divided by 3 is 4. Nice. All right, last step. Yeah. Good. So that would be the 5. So -5. -5. Nice. -1. Good. Yeah. Plus -1 or -1. Yep. Good. Nice job. So we got 4 more. I'm going to give you 10 minutes. Maybe a little bit less than 10 minutes. Let's say at 8:45. So 8 minutes. At 8:45, we are going to check the remainder of these 4. So be prepared to be called on just in case, but see if you can come up with answers for these 4. If you don't have an answer when I call on you, that's okay. We'll work through it together. But try these last 4 and we'll check back in 8 minutes. So at 8:45, we'll check these last 4 problems, which should hopefully give us about 20 minutes of work time. If you're not done with the 4 additional problems, that's okay. We'll just go ahead and start taking a look through these. Double check the ones that you have. We're working on 9, 11, 13, and 15. The even ones I will put on Google Classroom if you want to check those later. So with number 9, the thing that I'm noticing as I'm going around the classroom is if you have, basically when you write your point slope equation, it's going to look kind of opposite of what these x and y's are when you put them into the equation. If it's a negative number, you're going to do a plus with that in the equation. If it's a positive number, you're going to have a minus with that in the equation. So when we write number 9, we're going to write y plus 9 equals -2/5 times x minus 5. So that's our equation that we're going to start off with for number 9. Because again, the point slope formula has a minus in it. And so if this is a -9, minus -9 is plus 9. And over here, x, the minus is part of the equation, -5. That's where that comes from right there. All right, now we're going to do our 2 steps. The first step is to distribute. So we are going to distribute -2/5 to the x and to the -5. So we're going to leave the y plus 9 alone for now. So it'll be y plus 9 equals, the fraction times x is just the fraction with x. So -2/5x. And if you want to use a calculator for this fraction multiplication, you are welcome to do that. But we're looking at -2. So numerator times whole number times -5. -2 times -5 is +10. Positive 10 divided by 5. Now we divide by the denominator. So 10 divided by 5 is a positive 2. So we get y plus 9 equals negative 2 over 5x plus 2. That is after step 1. Now the second step, we have to get rid of this plus 9 over here with this y. So that means we're subtracting 9 from both sides. And that will give us y equals negative 2 over 5x. 2 minus 9 is negative 7. So minus 7. So our answer for number 9 is right here. Y equals negative 2 over 5x minus 7. Are there any questions about number 9 before we take a look at number 11? All right. Now in number 11, when we write our initial equation, we're going to have pluses with the y and the x because both the x and the y are negative numbers. I know it sounds a little backwards, but when there's a negative number, we're subtracting that number, which means it turns it into, not turns it into, but it makes it a plus. So we get y plus 1 equals negative 4 over 3 times x plus 6. So that's our initial equation there for number 11. All right, from there, we start our algebra. So we're going to distribute negative 4/3 first. The left side stays the same, y plus 1. Negative 4/3 times x, just put the x right next to the fraction, negative 4 over 3x. Negative 4 over 3 times 6. We're going to take our negative 4, multiply it by the whole number, 6. Negative 4 times 6 is negative 24. And then we divide that number by the denominator. Negative 24 divided by 3 is negative 8. So that's negative 4 over 3x minus 8. Our second and final step here, get rid of the plus 1. So we have to subtract 1 from both sides of the equation, which gives us a slope-intercept form of y equals negative 4 over 3x. Negative 8 minus 1 is negative 9. So we get y equals negative 4 over 3x minus 9 for number 11. Make sure you have that written down. Change anything if you need to. If you have questions, let me know. We'll move on to number 13, which 13 was funky if you worked on this one. All right, 13. We've got an x1 of 3, a y1 of negative 4, and a slope of 0. Before we even start number 13, what does a slope of 0 mean for the graph of this? Think about what a slope of 0 actually means on a graph. What does that look like? Anybody remember? No? It's a horizontal line. Yep. Slope of 0 means we have a horizontal line. And last Thursday, we saw equations of horizontal and vertical lines. And because m is 0, we have a horizontal line. And a horizontal line is always defined just by the y-intercept, by the value of y. There is no value of x in a slope-intercept equation for a horizontal line. So let's keep that in mind as we go through problem number 13. So here we go. Point slope form, we're going to have y minus negative 4, so y plus 4 equals the slope 0 times x minus 3. We've got two steps here. We're going to start by distributing as 0. This is where things get a little bit interesting. When you multiply anything by 0, what happens? The what? Yeah, it should be nothing, turns to 0. Even when you multiply a variable by it, it still turns the entire thing into 0. So we're going to get y plus 4 equals, you could write 0x minus 0, or you could just write 0. Because 0 times x is still just 0. So the x is gone, which makes sense with our equations of horizontal lines that we saw last Thursday. There is no x in the equation of a horizontal line. The slope of 0 makes the whole thing go to 0. So then we got to get y by itself. So we'll subtract 4 from both sides. And that means that y equals -4. And that is the answer. When you have a horizontal line, a slope of 0, the equation is just y equals a number, which is exactly what we got here. That's what we wanted. All right, last one that we're going to do as a class here, number 15. We're going to have y minus 1 equals our slope, -1/4, times x minus -4, which looks like x plus 4. So there's our point slope equation. 2 steps. First step, distribute the -1/4. Nothing changes on the left-hand side. It's still y minus 1. -1/4 times x is just the fraction and then the variable. So -1/4x. -1/4 times +4 is -1. So the last thing we need to do here, get rid of that in the -1 by adding 1 to both sides. So +1, +1. That equals, the y equals -1/4x. You can leave it like that, or what we've been doing with slope-intercept is we've been writing the 0 in, just to remind ourselves that that would be the y-intercept. So you can leave it as just -1/4x, or you can write -1/4x plus 0, just as a reminder on what that y-intercept needs to be. All right. So we're going to leave it at that. I will post the answers to the evens on Google Classroom when I post those notes on there, if you want to check those out later. But I want to make sure you've got time to work. Today's assignment is only 10 questions. It is one side of a piece of paper. We're not on the back. Every single question is just like the ones we did. So we've got about 13 minutes to get started on this. So use this time to get started.